Hello, and welcome to Statistics Math 201 and watching videos for this semester. So how this will go is every lesson there will be a video for you to watch, and there will be assignments accordingly. Those will all show up in Canvas. I will be, the notes that I provided, I encourage you to print out so that you can write what I'm writing and notes for your extra notes for yourself on those notes. Then you can compile those for the semester. I will be asking you to periodically for each chapter, scan in certain lessons that you have printed out and written notes for. It won't be for every lesson, as that would be quite a few pages. But I just want to ensure that you are watching the notes and you're engaging in class, and that's part of your participation for the semester. So we're going to start with lesson 1.1, and here we go. I will be sharing my my notes with you as I get this all set up here. And we're starting with chapter 1. So chapter 1 is kind of like the building blocks for the rest of the semester. So I'm going to be covering a broad range of things in chapter 1. And then throughout the semester, we'll always refer back to these little bits and pieces here. So first of all is statistics. What is statistics? Statistics can be thought of in lots of different parts of our English language. And we can think of statistics as collection. So collecting data, analysis, we're going to analyze data. We're going to interpret and also do some presentation of data this semester. So sometimes we talk about statistics like there's things, like a noun. And sometimes we talk about doing statistics like it's a verb. And sometimes we talk about statistics kind of like describing something as an adjective. So like I said, we're going to be thinking about statistics in all of these different ways this semester. There's two types of statistics that we're going to look at this semester. And really they should be flipped around because we work on descriptive statistics first. So descriptive statistics organize and describe summarize data. Okay. Inferential statistics is used to takes data from a sample and uses that to infer or tell about the population. And we're going to talk about sample and population down below. So let's just jump down and do that. So population sample. So population is the entire group of subjects we want to learn about. Okay. The entire group of subjects. Sometimes the subjects are a car, sometimes it's an animal, sometimes it's a human. So don't always assume it's a person that we're talking about when we talk about subjects. Okay. Now, sometimes, most of the time in real life, you never have all of the data from the population. It's very rare that you're getting all of the data. That's why we use a sample. So a sample is going to be a subset of the population. Set of the population. And we do know the sample. So if I were to say I wanted to learn the number of siblings from every student at Glen Oaks Community College, it would be hard for me to do that and unrealistic. So I would get a sample of the students at Glen Oaks Community College, and I would ask them the number of siblings that they have. So if I were to ask that question, the number of siblings, the parameter would be the characteristic from the population and you can remember that parameter describes the population because they both begin with P. And the statistic is the characteristic that describes the sample and so the characteristic, if we were to ask the number of siblings, so the number of siblings would be the statistic from the sample, and the number of siblings, if we knew the entire data from all of the Glen Oaks Community College students, that would be the parameter. So the cool thing is like I said, P goes with P for parameter goes with population, and the statistic goes with the sample, okay? And we're going to look at two different types of parameters and statistics this semester. I'm kind of getting ahead of myself, but I'd like to introduce things as often as I could. And we're going to be talking about the population mean, and that will be using this symbol. It's a Greek symbol called mu, is how we pronounce that. And then we're also going to be talking about the population proportion, and we're going to use a capital letter P to describe that there. Now, the mean of the sample is a statistic, and so the mean of the sample is going to be used just a regular letter from the alphabet. And we use the symbol X bar, we pronounce that X bar, to describe the average of the sample, and the proportion of the sample. We use something called, the book I use, P hat is what it's called, or P prime. I might say there's like a quote there to describe the proportion of the sample. So, like I said, we're going to be talking about inferential and descriptive statistics. Descriptive statistics is going to be mainly chapters 2 through 4. And then inferential is going to be mainly chapters 8 through 12, the chapters that we're working on. So you can, I highly suggest that you go through the book, whether you're using the online book or the hard covered book that you purchased maybe, and reading. There's lots of definitions that we're not going to particularly cover in the notes that are good to go through on pages like 5 through 11 in the book. So we're also going to be talking about probability this semester. And probability does have a lot to do with probability based on descriptive statistics, but also probability to help us to use this inferential statistics. And we're going to go by probability as a definition of probability is a mathematical tool a mathematical tool used to study randomness. And we talk about probability all the time in our daily lives. For an example, if you watch the weather, if you go to your weather app, it tells us that today there's an 80% chance of rain. And does that mean that 80% of the day it's going to rain? Or does that mean 80% of the viewing area it's going to rain for sure? So there's lots of ways to interpret that 80%. If you watch sports, you can, now there's gambling, right? Legal in Michigan. There's a lot of probability going on in sports. Like, what is the probability that LeBron James will win another championship? What is the probability that Matt Stafford throws 4 touchdowns in a game? So that's using prior historical data to inform you on the likelihood of something happening. So that's how we're going to use probability. That's going to come into play in chapter 4. Okay, so let's move on a little bit. So it says determine what the key terms, we're going to go to our first example here. Determine what the key terms refer to in the following study. We want to know the average mean amount of money first-year college students spend at ABC College on school supplies that do not include books. We randomly surveyed 100 first-year students at the college. 3 of those students spent $150, $200, and $225 respectively. Now, in the assignment that you're going to work on for chapter 1, it says, answer the key terms. So when it states that in the assignment, these are the key terms. There's 6 of them that I want you to describe for this situation: the population, the sample, the parameter, the statistic, and the variable and the data. Remember that the parameter goes with the population and the statistic goes with the sample. So let's go through this example together. The population would be all first-year students attending ABC College this term. Always use the word all to describe your population. The sample could be all students enrolled in one section of a beginning statistics course at ABC College, although this sample may not represent the entire population. A parameter. The parameter could be the average amount of money spent, excluding books, by first-year college students at ABC College this term. And so the parameter, remember, that is going to be the descriptive characteristic that describes the population. Now, the statistic is what's describing the sample. So that could be the average amount of money spent by first-year college students in the sample. So we would find the average spent by these 3 particular students up here. The variable in this case could be the amount of money spent, excluding books, by one first-year student. So that would be X. What is the actual value or thing that we're collecting, information we're gathering? That's our variable. And then the data are the dollar amount spent by the first-year students. And that would be the 150, the 200, and the 225. So there are a couple, you try it. Sometimes I call them you try it. That's what the book kind of refers to them. They're examples that we're going to look at, that we're going to go through for our examples here. So that's going to be data down here. Okay. So the first question says, determine what the key terms refer to in the following study. We want to know the average amount of money spent on school uniforms each year by families with children at Knoll Academy. We randomly survey 100 families with children in the school. 3 of the families spent $65, $75, and $95 respectively. So the population would be all families with children at Knoll Academy. And this, the sample, well, I got these mixed around. The sample is what we would do next. The sample would be the 100 families that have children at Knoll. The parameter should be next. The parameter is the mean amount families, and it would be all families because we're referring to the population. The mean amount all families spent on uniforms. Okay, so the parameter goes with the population. And then the statistics would be the mean amount, the 100 families, because the statistic refers to the sample, the mean amount the 100 families spent on uniforms. The variable that we're actually collecting data on is going to be represented by X, and it is the amount one family spent on uniforms. And we're going to collect that amount from all 100 families in the sample. And then the data would be the example that we have here of the three pieces. So the dollar amounts spent on uniforms, and then we would list what we spent. And so the data that we have so far is 65, 75, and 95. So look these over here. Okay. The second you try it for lesson 1.1 is determine what the key terms are in the following study. An insurance company would like to determine the proportion of all medical doctors who have been involved in one or more malpractice lawsuits. The company selects 500 doctors at random from a professional directory and determines the number in the sample who have been involved in malpractice lawsuit. So the population would be all, I think they want to look at all medical doctors. And I think it'd be safe to assume in the US. The sample would be the 500 doctors chosen at random from the directory. The parameter would be the proportion and a proportion, as we go through this, you'll see the proportion actually means, usually we say percentage. So we use a proportion as a fraction turned into a percentage. The proportion of all doctors, remember it refers to the population of all doctors who have had a lawsuit. And the statistics would be the proportion of the 500 who have had a malpractice lawsuit. And the variable is going to be X is equal to the number of doctors who have had a lawsuit and the data would be those that said yes, they have. And that is all for lesson 1.1. Catch me back.